So all of you should already be ready to go. You guys, my expectation is as soon as you walk in my classroom, you're writing your homework down, you're getting your homework out if we had homework. If you don't, you're getting your notes out. Those of you that are ready to go right now, I really, really, really appreciate it. Those of you that aren't, I don't know what to tell you. The only thing that you shouldn't have had out necessarily was the ruler, because I didn't tell you to as soon as I walked in. All right, Chapter 2, Section 8. What we're going to be talking about are inequalities and their graphs. Inequalities and their graphs. Okay. I first need to kind of go over with you what an inequality is. All right, so let's do a quick comparison between equations versus inequalities. So equations versus inequalities. An equation looks something like 2x equals 8. That's an example of an equation. It has an equal sign. I could write exactly the same looking equation, but make it an inequality. So I could say 2x is greater than 8. So the only difference between an equation and an inequality is that symbol between the two expressions. So here we have an inequality symbol between the two expressions. In an equation, we have an equal sign between the two expressions. Okay, let's talk about solutions. Oh no, let's talk about inequality symbols. Well, I already did one of them. This is a greater than. What is another inequality symbol? What's another inequality symbol? Dominic? Less than. Alex, give me another one. Or did we steal it? Did we steal yours? All right, well, there's two more. Frankie? Not equal to. Equal to is not an inequality symbol, but you're on the right path. Romano? Excellent. Greater than or equal to. All right, so it has the greater than symbol. A greater than symbol has the bigger part coming first. So this is greater than or equal to. That part of an equal sign, that one line from the equal sign, is the equal to. What's the last one? Angela? Excellent. Less than or equal to. When you're reading from left to right, if the smaller part comes first, that's the less than. If the bigger part comes first, that's the greater than. Just so you guys know how to say those. How many of you guys remember those symbols? Okay. We don't use them all the time, so we don't always remember them off the top of our head. But once somebody says one, you're like, oh yeah, I remember the rest of those. Let's talk about solutions. Solutions to equations. I want to start with that because we've already done solutions to equations. A solution to an equation is going to look something like x equals 3. A solution to an inequality is going to look something like x is greater than 3. So from a visual standpoint, that's the difference visually in the solution of what, when we're done solving the equation, what our solution is going to look like. All right. when we talk about graphing solutions, we typically don't graph solutions when we have an equation. When we get to linear equations where we have two variables, we will. But here, when we just have one variable, we typically don't graph our solutions, but we could. So what we're going to do is we're going to use a number line. You're drawing a number line on one of your grid lines, please. This is why we have graph paper. All right, put some arrows at the ends of your number line. Always find our 0. I'm going to kind of put it a bit in the middle. I could put it to the left a little bit because I have to go out to 3. If you're counting by ones, I don't need to see what you're counting by. All right, but at least put 0 on there and then the value that is our variable. And if I graphed x equals 3, it's just this dot. So that dot represents x equals 3. And again, normally we don't graph solutions to equations. But if we did, that's what it would look like, because x equals 3. Let's compare that to inequalities solutions, which are a little bit different. We're still going to start with our number line. I call that value with our variable our start number. I call that our start number because that's where the values for our variables start. All right, so here's my 0. All right, there are a couple things that we need. There's 2 elements that we need to graph inequalities. All right, so we have 2 elements that we need to graph. The first one is our dot. Our dot here for the x equals 3 was just a closed-in dot. All right, we have 2 possibilities for this. We have what's called a closed dot, and our closed dot is our less than or equal to or our greater than or equal to. What that means is our start number is included in the solution. Our start number is included in the solution. The other one is an open dot. This is a less than or a greater than. And what that means is the start number is not part of solution. It's just where we're starting from. So for ours that we're doing here, so our start number is a 3. So my dot's going to go on our 3. Am I going to have an open dot here or a closed dot? Based on this solution, we're graphing that. So we're graphing x is greater than 3. So is it going to be an open dot or a closed dot? Mateo? It's going to be an open dot. Why? Exactly. So we have a greater than here, right? Okay. The second thing we have, and I'm going to do this over here just because I would like it on the same page. The second thing we have is our shading. You guys probably have more room than I do because I write really big. Our shading. This is all the possible values for the variable. Those are all the possible values for the variable. So tell me, this says x is greater than 3. So what are all my x's in relation to my 3? Are they bigger than my 3 or smaller than my 3? This says x is greater than 3. The bigger part is facing the x, so x is greater than 3. So what are all my x's in relation to my 3? Come on, all of you, think. This says x is greater than 3. So what are all the possible values for my x if this says x is greater than 3? Aaron? All the numbers that are greater than 3. All the numbers bigger than 3 is where I'm shading. So I'm just going to kind of do like this little shading, shade it in a little with an arrow on the end saying it keeps going. So this shading are all possible values for x. Questions so far? Okay, so what I want to do is I'm going to give you a couple of solutions that I want you to graph. Audrey, what do you need to see? This? All right, so I'm going to give you 4 solutions, 4 inequality solutions that I want you to graph. So the shading are all possible values for the variable. All right, so when you're figuring out your shading, you're looking to see what side of the inequality is facing the variable. Because the variable will not always come first, okay? So I want you to graph the following solutions. All right, my first one is y is less than 3. I'm going to put all 4 of them up. Go ahead and get started on that one. So there are all 4 of them. You're graphing them all on a different graph. Shading doesn't have to go all the way to the end of your line, just far enough that I can see where you shade. And make sure there's an arrow at the end. And I need to see what kind of dot you have. So be careful that your shading and your dot aren't running into each other, that if you have an open dot and you shaded into it, that I can't see that it's open. You know what I mean? Alright, and you're using your number, like your ruler, needs to go on a grid line, not hanging out in the middle of nowhere. You guys are using your ruler to draw these number lines. Your number lines should be on a grid line. They should not just be in the middle of nowhere. The last 2, be very careful on the last 2. Remember, you're looking to see what side of the inequality symbol is facing the variable. Alright? Not what does the inequality say. Or the last 2, I did it on purpose to trick you. Alright, but if you're doing what I'm telling you, Look and see what side of the inequality is facing the variable, and that's the way that you shade. When you're done, check with someone sitting by you, see if you guys have the same solutions. If you don't, you have to chalk it out. Put these dots on the number line, not above. So you guys, I want those dots on the number line at the start number. Your shading does not have to be obnoxious. As long as I can see that it's darker than the number line and which side you're going towards for shading, that's fine with me. Now, if you're not sure what the dot is, go back into our notes and see. When do I have an open dot? When do I have a closed dot? Because they're all not the same on this. You should not have all open dots here. You should not have all closed dots here. Look and see what the criteria are. Yeah. So that's the number that your dot is at.
Oh, okay.
So on this one, the number 1, the start number is 3. Number 2, the start number is -1. It's the number that's in the solution, and that's just where the dot goes. And that's what shading goes from. So in a closed dot, it's closed because it's equal to as well. I'm talking. Do you hear me talking? Why are you going to say my name? Do you know that I'm answering your question? So, do you think your needs are above her needs? Then you're going to wait patiently, please. A closed dot means that you have either a greater than or equal to or a less than or equal to. The equal to part means that your start number is part of the solution. Okay? The shading is what all the rest of the numbers could possibly be. In an open dot, like number 1 and number 4, all right, in number 1, it's an open dot at the 3, because 3 is not part of the solution. That's just where all the solutions start from. That's the number our solutions start from. When it's an equal to, it includes it, which is a closed dot. If it is not an equal to as part of it, it's an open dot, because they just start there. They do not include that as well. That's the start number. That's where all the solutions start from. Do you understand? Okay. Mateo, what can I do for you? I'm sorry? Come see me after class. All right. So let's take a look at that first one. So you have a number line on a grid line. Here's my 0. My start numbers are 3. So all my solutions start from that 3. It's an open dot because 3 is not, because it's a less than symbol, not a less than or equal to. So there's my dot. It's at my start number, which is my 3. What are all my possible values for my variables? If this says y is less than 3, what are all the possible values for my variables? Kira? More than 3 or less than 3? Anything less than 3. So I'm just going to shade all the values on my number line less than 3. So these are all my possible x's. Or y's. Is the shading. Yes, Mateo. No, I'm teaching you. All I need is the graph. The graph. All right. Somebody tell me how to graph the second one. Someone tell me how to graph the second one. Aaron? Excellent. Why is it a closed dot? Excellent. And what are all my variables in relation to that negative 1? Yeah, they're more than, because the bigger side of my inequality is facing the variable. Excellent. All right, so 3 is a trickier one. So someone tell me how to do number 3. 3 is a trickier one. Here's my 0. Alex? Okay. Shh. Closed out. Why is it closed? Excellent. And what are all my variables in relation to that negative 2? They're smaller, right? Why do you know that they're smaller? Exactly. That negative 2 is greater than all of my A's. So all of my A's must be less than my negative 2. Nice job. All right. How about that last one? Who wants to graph for us that last one? Angela, go ahead. Excellent. Why? Excellent. The less than symbol? Good, it's okay. And what are all my variables in relation to that negative 6? Excellent. Yep, everything bigger than it, because the bigger side of my inequality is facing the A. Dominic. You can do whatever you'd like. If you'd like to use a color, you can highlight it. That's fine. But Dominic, I need to know, you can't use the highlighter on your dot, because I need to know what the dot is. Now, highlighters, I'm not going to know if it's filled in or not. So use your pencil or a pen to create the dot, and then if you want the highlighter for the rest, you can. Questions on graphing this? Okay, so now what I want you to do is I'm going to give you graphs, and you're going to tell me what the inequality solution is. So I want you to state the solution from a graph. I want you to state a solution from a graph. So here's my first problem. So here's my number line. Remember, those number lines have to be on grid lines. Remember, if I don't put any numbers on there, that means I'm counting by ones. I always put my start number on there, though. All right. So the first thing I want to do is I want to identify the start number. So in this example, what is my start number? Romano? 0. All right, then you can use any variable you want. All right, so I'm going to do x, and then I'm going to do 0. Okay, the next thing is you need to determine the inequality symbol. All right, so is this an open dot or a closed dot? So is this an open dot or a closed dot? Audrey? This is open. So this is open. So my possibilities are a greater than or less than or greater than. All right. So the next thing is we have to look at our shading. Which direction is my shading going? Is it going, are my possible x's bigger than my 0 or less than my 0? Emerson? They're bigger. So I'm going to have my bigger side of my inequality facing my variable. So here, the shading is bigger than the 0. So, the greater than symbol, God bless you, is used. Alex. No, I just want you to write the solution. Here. When you're doing these, when you're writing a solution, I do want the variable coming first. Now, when you're given equations, tomorrow when we start doing solving equations, it might be that your variable is on the right side, but the correct way to write a solution to anything, equation or inequality, is the variable coming first. So always have that variable coming first. All right, so let me give you guys another one. Who needs to see what's up there? Okay. So I want you guys to state the solution. I'm going to give you two of them. So there's your first one, and I'll put the second one up. Now on that second one, if you noticed, I did not tell you what the start number is. So I want you to read the graph, look at the increments, and you tell me what that start number should be. If you notice, I've put a -2 and a +2 on either side of my 0. So that's indicating I'm counting by 2s. Right, when I don't put anything on there, you're counting by 1s. When you're done, check with someone sitting by you. Who needs to see what's up there? All right, tell me, what am I going to do? Somebody give me my solution to the first one. Mateo? Okay, hang on one second.
Please pardon the interruption. Mr. Vinsler, would you please report to the front office? Mr. Vinsler, please report to the front office. Thank you.
What variable did you use? Okay. Is it equal to as well? Why? Okay. You guys, did any of you guys hear me? Kira, did you ask the question? Who asked the question? Was it Kira? Did anyone hear the question she had for me? Kira, what was your question that you had for me before? That I just said out loud to all of you. Layla, do you remember? What was it? Does it matter if the variable goes first or second? And what was my answer? So what should you guys have for this? So, Mateo, why I don't disagree with what you said, what did I tell you guys is the proper right way to write a solution? The variable always comes first. So I don't disagree with you that -2 is greater than or equal to x is correct. I want you guys writing them the right way from the beginning. So I would like the variables to be coming first, please. All right, nice job on that, though. Someone do the second one for me. Addison? Shh. Excellent. Excellent. How many of you guys got those right? Okay. All right, so now let's talk about if we're given phrases, how we know if it's a greater than or equal to, greater than, less than or equal to, less than, okay? So let's talk about phrases and inequality symbols. So if I have this one, this is a less than. But if I was to read phrases in math, what would go with a less than? What phrase might go with a less than? If I'm reading something. Alex, what do you think? These are hard, aren't they? Yeah, I might see less than as well. That is a phrase that we might see is less than. If I have a less than or equal to, what phrase might go with a less than or equal to? What phrase might go with a less than or equal to? Jack? Not at least. So if I have less than or equal to, that means all the possible values. So if I take a look at this right here, less than or equal to -2. How else could I explain what that says instead of saying less than or equal to? Jack, you were on the right track. You just said the wrong phrase that went with that. Angela? I'm asking you what phrase goes with less than or equal to. Like, what might you read that you're like, oh, that must be less than or equal to -2. What might it say? Kira? No, I don't like that. Yes, but that's probably not what you're going to see in a... Think about when you're reading something like in a story problem. I like that you're thinking that way. I want you thinking of other ways that we can say it. All right? How about at most? Does that make sense? Right? At most. How about no more than? Or a maximum of? Don't you guys, does that make sense that those go with less than or equal to? Right? How about greater than or equal to? So Jack, that's what I wanted you to think about. Because you were on the right track. Give me another phrase that we might read in math, like in a story problem, where we might put the greater than or equal to symbol in there. Use my less than or equal to as kind of your guide. What might we find in a phrase that we're like, oh, that must mean x is greater than or equal to 2? Kira? At least. What's another one? Come on. Read what I have up here and do something similar. What's another one? Christiana? Minimum of. Give me another one. Aaron? Sure. No less than. You guys with me? Okay. So, remember, I want the variables coming first. All right, so I want to show you this, and I want you guys to do this, what this says. So you're using this table of data. All right, so it says, food can be labeled low sodium only if it meets the requirements established by the federal government. All right, so it can only be labeled as low sodium if it meets the requirements established by the federal government. Use the table to write an inequality for this requirement. So we want low sodium, and we want to write an inequality for the low sodium. So all of you do this, please. You're putting this table into your notes, because this is our given. And then state what we're asking for you to do, so you can go back to this and use it as a guide in your homework, which is what all of you should be doing. So you're choosing a variable, and you're writing an equality for the information there for low sodium food. So you want to write an inequality representing requirement for low sodium food. Bless you. So here's the table. This is what you need to be doing. Write an inequality representing the requirement for low sodium food. So choose a variable, write an equality with the information. All right, so someone help me out. Low sodium food. Someone write this inequality for me. So clearly I'm using that bottom tier of information. Pick a variable, write the inequality. Alex? You can't do less than or greater to. So it's either less than or equal to, greater than or equal to, less than or greater than. Why less than or equal to? Excellent. We have this at most. So we know that that is the maximum that the sodium can be. So I have less than or equal to because it's at most. How many of you guys had that? All right, I want you guys to write the same thing for sodium free and for very low sodium. So what would the inequality for sodium-free be? Kira? Why only less than? Yep, so it doesn't include it as well. And I like that you reminded me to put milligrams on there. So make sure you put the units on there as well. So milligrams. Excellent. Someone do the very low sodium for me. Michaela? Y less than or equal to. Excellent. Can you guys see how this works? Okay, so we've been exploring, we're all done, we've been exploring inequality solutions, how to write them, how to graph them, how to get them off of a graph. All right, so tonight's homework is just dealing with these inequality solutions. So please use your notes as your guide. Please use your notes as your guide.